Picture a future where spacecraft navigate the vastness of space with the prowess, flexibility, and resilience found in the natural world. This isn't a tale spun from science fiction, but a growing reality where the groundbreaking field of biomimicry is taking center stage. Today, we set out on an exploration into how this innovative approach is reshaping the way we design space technology by taking cues from nature's long-evolved solutions. Imagine spacecraft shields designed with the impenetrable strength of the pangolin scales or propulsion systems as efficient as a bird's flight. Nature has perfected these designs over millions of years, and we are now on the cusp of integrating this wisdom into our quest for the stars. But why is biomimicry the key to our future beyond Earth? As we set our sights on Mars and destinations even more distant, the need for adaptable and robust spacecraft becomes paramount. Can the lessons coded within the very fabric of life on Earth help us overcome the challenges of extraterrestrial environments? Stay with us as we uncover how the blueprints of nature may hold the secrets to not only surviving but thriving in space. In this video, we delve into the ways that nature's genius inspires the future of space exploration, opening doors to possibilities previously beyond our reach. As the next challenge unfolds, let's delve into the fascinating origins and the fundamental principles of biomimicry, an approach that revolutionizes the way we solve complex human problems by drawing inspiration from nature. At its core, biomimicry is all about observing and emulating what nature has already perfected over millions of years. This design philosophy revolves around three levels: form, process, and system, each offering unique insights and opportunities for innovation. Firstly, the form level focuses on the physical structures of organisms. Think about the lightweight yet sturdy design of a bird's wing or the water-repellent surface of a lotus leaf. By examining these forms, engineers can design sleeker, more aerodynamic vehicles or create materials that resist water and dirt naturally. The process level takes this a step further by considering the biological processes that allow living organisms to thrive. Photosynthesis is a perfect example, as it converts sunlight into energy efficiently, inspiring solar technologies that power our homes and cities. The system level is perhaps the most holistic, encouraging us to view ecosystems as entire entities. By understanding how different species coexist and support each other in their environments, we can create more sustainable technologies and systems. Imagine city infrastructure that mimics the interconnectedness of a rainforest, where waste from one process becomes the input for another, minimizing resource use and maximizing efficiency. Now, what if we could translate these principles to space exploration? Picture spacecraft designed to adapt and thrive just like the organisms here on Earth. This is not just a dream, but a burgeoning reality. By applying these levels of biomimicry, we could develop spacecraft with the same agility and resilience as a living creature. A spacecraft that changes its shape based on external conditions or utilizes energy as efficiently as a plant could redefine how we explore the cosmos. Industries on Earth are already seeing transformations thanks to biomimicry. From bullet trains designed to mimic the streamlined beak of the kingfisher to buildings with natural ventilation systems inspired by termite mounds, the potential applications are vast. Space exploration stands on the threshold of this new frontier, ready to adopt nature's blueprints for survival and efficiency. With the next phase of the journey in sight, we face the promising challenge of harnessing nature's genius to propel us further into the stars. Can the designs that have allowed life to flourish on Earth guide us as we set our sights on the cosmos? As we continue, we'll explore how historical successes in biomimicry are shaping the possibilities of the future, leading us towards a new era of sustainable and resilient space technology. Moving forward, let's explore remarkable success stories where biomimicry has already made a significant impact on space technology. These successes not only showcase the potential of this approach, but also set the stage for future innovations that could revolutionize our journey into the cosmos. One notable example is the study of geckos, known for their incredible ability to adhere to surfaces without any adhesive. NASA has taken inspiration from these small creatures to develop advanced adhesive technologies. By mimicking the unique structure of gecko feet, researchers have created surfaces that can securely attach and detach in the vacuum of space. Imagine how this could transform future spacecraft maintenance, allowing for repairs and adjustments that currently require complex tools and procedures. Another example comes from the world of high-speed train design, specifically the Shinkansen in Japan. The kingfisher bird, with its unique beak shape, inspired engineers to redesign the train's nose to reduce noise and increase speed efficiency when emerging from tunnels. This innovation not only improved train performance but also demonstrated biomimicry's potential across various fields. By applying these insights to space technology, engineers could significantly enhance the aerodynamics and fuel efficiency of spacecraft, making long-distance space travel more viable. These trailblazers in biomimicry provide a blueprint for future endeavors in space exploration. They demonstrate how a nuanced understanding of nature's designs can lead to tangible improvements in technology. The groundwork laid by these inventive breakthroughs is paving the way for a new generation of resilient spacecraft. As researchers continue to draw inspiration from the natural world, the possibilities for innovation are endless. Imagine spacecraft that can repair themselves much like human skin or solar panels that mimic the energy conversion efficiency of photosynthesis. These advancements could redefine our approach to space exploration, making it more sustainable and adaptable to the challenges of the cosmos. By learning from nature, we open our minds to a wealth of possibilities, creating a future where the boundaries of exploration are limitless. As we look to the stars, let us carry forward the lessons nature has taught us, using them as a guide to navigate the uncharted territories of space. Now turning to our first strategy in biomimicry, we delve into the fascinating world of natural materials to develop resilient spacecraft. At the forefront of these efforts is spider silk, a material renowned for its exceptional strength, lightweight properties, and remarkable flexibility. Unlike traditional materials used in space engineering, spider silk offers an intriguing alternative due to its unique characteristics. Imagine a spacecraft built from materials that are stronger than steel yet as light as a feather, capable of withstanding the harsh conditions of space with ease. Spider silk's potential doesn't just end with its mechanical properties. Its ability to absorb and dissipate energy can be crucial in protecting spacecraft from impacts by space debris, which is a growing concern in our quest to explore the cosmos. Researchers are keenly studying this wonder of nature, aiming to replicate its structure and production in labs. The goal is not just to mimic the strength, but to harness the silk's entire range of properties to create a material that is both incredibly resilient and sustainable for space travel. As we explore deeper, the science behind spider silk offers more than just practical benefits. It provides a glimpse into a future where spacecraft materials are not just static entities, but dynamic solutions tailored to meet the ever-changing demands of space travel. By integrating these natural designs into our technology, we can potentially cut down on the weight and cost of launching materials into orbit, thereby making space travel more efficient and environmentally friendly. The integration of spider silk-inspired materials into spacecraft design represents a pivotal moment in the evolution of space exploration. It signals a shift from relying solely on synthetic materials to embracing the wisdom of nature, which has perfected the art of resilience over millions of years. This approach opens up new avenues for innovation, suggesting that the materials of tomorrow may very well be crafted from the lessons learned from nature's own creations. As we embrace the potential of spider silk in spacecraft engineering, we set the stage for transformative advancements in space technology. This fusion of cutting-edge material science with the age-old ingenuity of nature not only revolutionizes how we think about building spacecraft, but also challenges us to continually seek inspiration from the world around us. By doing so, we stand on the brink of perhaps one of the most exciting eras in space exploration, where the materials we use are as sophisticated and adaptable as the journey itself. With this foundation, the possibilities for future innovation are indeed endless. With the next phase of the journey in sight, we explore our second strategy in biomimicry, focusing on adaptive structures inspired by nature. Imagine the intricate mechanism of a Venus flytrap responding swiftly to the slightest touch, or the way pine cones open and close depending on humidity levels. These natural marvels offer valuable insights for designing spacecraft that can dynamically respond to the unforgiving conditions of space. Picture a spacecraft that, much like the Venus flytrap, can shift its shape to maintain functionality despite extreme conditions. It could adjust its structure in real time, providing optimal protection and performance against fluctuating temperatures, radiation, and micrometeoroid impacts. This concept could redefine resilience in space travel, enhancing both the durability and longevity of the spacecraft. The potential applications of such adaptive structures are vast. For instance, consider a craft's outer shell that expands or contracts to regulate thermal conditions, similar to how certain plants manage climate changes. This would not only improve energy efficiency by minimizing reliance on active thermal control systems, but also significantly reduce the risk of thermal-induced material stress, a common challenge in space missions. In addition, biomimetic designs could lead to innovations such as self-deploying solar panels, offering flexibility in energy harnessing and storage. These panels could unfold seamlessly as the spacecraft exits the Earth's atmosphere, maximizing exposure to sunlight, and retract when navigating through space debris zones to minimize potential damage. Furthermore, adaptive structures might emulate the robust yet flexible architecture of natural forms like honeycombs or tree branches, offering strength without sacrificing elasticity. Such designs could also enhance payload capacity, allowing spacecraft to carry more equipment or resources without compromising structural integrity. The integration of adaptive features into spacecraft design not only promises enhanced survival in the hostile environment of space, but also paves the way for more sustainable and cost-effective missions. As we stand at the threshold of this transformative approach, it becomes evident that nature's adaptability can inspire a new generation of spacecraft. By harnessing these principles, we are not simply copying natural phenomena, but are learning to coexist with nature's laws. This fusion of technology and biology sets the stage for groundbreaking advancements in space exploration. As we continue to draw inspiration from nature's ingenious designs, we are reminded of the boundless potential for discovery that lies ahead. And with each step forward, we get closer to realizing a future where our spacecraft are as dynamic and adaptable as the natural world that inspired them. As the sun rises on the next chapter, we turn our attention to the third strategy, energy efficiency through biomimicry. In the vessel of innovation, nature provides us with the blueprint for optimizing energy consumption in space exploration. Take, for instance, the marvel of photosynthesis, a process perfected over billions of years, allowing plants to convert sunlight into energy with remarkable efficiency. Imagine integrating this natural proficiency into spacecraft design. By mimicking natural processes such as photosynthesis, we could develop systems that efficiently harness and store solar energy, offering sustainable power solutions for long-duration space missions. Instead of relying heavily on traditional power sources and their associated costs, this biomimetic approach could reduce fuel needs, lower emissions, and enable longer missions with less environmental impact. Picture a spacecraft equipped with panels that convert sunlight into usable energy, not just storing it but distributing it efficiently to all systems on board, much like the leaves of a tree. This concept could revolutionize how we power our journeys across the cosmos. Moreover, the mechanics of birds in flight present another fascinating example of natural energy efficiency. Their ability to glide effortlessly through the skies with minimal energy expenditure offers insights into designing spacecraft that can travel vast distances without excessive fuel consumption. By studying avian flight patterns and wing structures, we can inspire adaptive wing designs and propulsion systems that maximize lift while minimizing drag. Such advancements would not only improve the energy efficiency of spacecraft during atmospheric exit and re-entry, but also enhance their maneuverability and speed during interplanetary travel. The potential benefits are immense, as these bio-inspired technologies could lead to significant reductions in energy consumption, making space exploration more viable and sustainable. Consider the implications of biomimetic energy systems not only for spacecraft but also for creating supportive habitats in space. By emulating natural energy cycles, we could design life support systems that mimic Earth's ecosystems, maintaining balance and sustainability in closed-loop environments. This approach would ensure that future space habitats are not just powered sustainably, but are also capable of supporting human life in harmony with their surroundings. The fusion of biology and technology in crafting energy-efficient spacecraft represents a leap forward in our quest for interplanetary exploration. By drawing inspiration from nature's ingenious strategies, we can unlock new potentials in space travel, ensuring that our voyages are not only bold and ambitious but also sustainable and respectful of the cosmic environments we seek to explore. As we propel forward, we find that the keys to our future in space may well lie in the ancient wisdom of our earthly neighbors. With nature as our guide, the horizon of exploration becomes limitless, leading us to a future where humanity thrives in harmony with the universe. Moving forward, we delve into the fascinating realm of self-healing materials, where the lines between biology and technology blur to forge new frontiers in space exploration. Imagine spacecraft that, much like living organisms, possess the capability to mend themselves when damaged. This self-repairing nature is inspired by biological processes such as the healing of human skin. Picture this, a spacecraft surface encountering the sharp edges of cosmic debris, only to initiate a self-repair mechanism that closes the breach just like a cut on human skin heals over time. This innovation draws heavily from nature's remarkable ability to regenerate and repair. Research into self-healing materials is advancing rapidly, with scientists exploring polymers and resins that can autonomously repair cracks and punctures. When integrated into spacecraft design, these materials could significantly reduce the need for human intervention by healing themselves in response to micrometeorite impacts or wear and tear from space debris. A leading example comes from the development of microcapsule-based systems, where tiny capsules embedded within a material release healing agents upon damage. This process closely resembles the clotting of blood, effectively sealing breaches and restoring structural integrity. Such technology holds the promise of extending the operational lifespan of spacecraft without constant human oversight, thereby increasing mission safety and reducing maintenance costs. Moreover, the potential applications of self-healing materials extend beyond structural repairs. They could be used in electronic circuits within spacecraft, self-correcting minor faults without the need for repairs from Earth. This would ensure continuous functionality and preserve critical systems during long-duration missions, a crucial factor in ensuring mission success. The concept of self-repair is not limited to individual spacecraft. Imagine entire space stations or habitats utilizing this technology, allowing them to maintain integrity in the face of unforeseen challenges. This would not only enhance the reliability of long-term space missions, but also ensure the safety and well-being of astronauts living and working in these environments. As we push further into the depths of the cosmos, the ability to autonomously repair damage becomes a vital strategy, one that could determine the success of our interplanetary endeavors. By embracing self-healing materials, we take another substantial step toward more resilient spacecraft, reducing dependency on Earth-based resources and increasing the autonomy of space missions. As traditional barriers to exploration begin to fall, this biomimetic approach offers a vision of the future where spacecraft are not only robust but adaptive, seamlessly integrating lessons from nature to meet the challenges of the cosmos head-on. As we progress, the dream of sustainable, long-term human presence in space edges close to reality, heralding a new age of exploration guided by the wisdom of the natural world. With our sights set firmly on the stars, self-healing materials emerge as a beacon of innovation, bridging the gap between what is and what could be. With the next phase of the journey in sight, we explore the remarkable world of navigation and sensory systems inspired by nature. Consider the intricate navigational abilities of migratory animals. Bats utilize echolocation, emitting sound waves that bounce off objects around them, allowing for precise movements in complete darkness. Meanwhile, birds possess an innate magnetic sense, guiding them across vast distances and diverse terrains with astounding accuracy. These extraordinary natural systems offer a treasure trove of insights for developing advanced navigation and sensory technologies in spacecraft. Imagine spacecraft equipped with systems that mimic the echolocation of bats. These would enable them to navigate through the dark and uncharted regions of space by sending out signals and analyzing their return to detect obstacles and chart their course. Such technology could be revolutionary in preventing collisions with space debris, safeguarding the spacecraft and its mission. Additionally, much like bats perceive their surroundings with sound, spacecraft could employ similar mechanisms to gather detailed information about their environment, enhancing their ability to operate autonomously in the most challenging conditions. Equally inspiring is the magnetic sense of migratory birds, which allows them to maintain precise routes over immense geographical expanses. Translating this capability to spacecraft could lead to onboard systems that sense and utilize solar magnetic fields to maintain a steady and accurate course. This approach could significantly enhance interplanetary navigation, reducing reliance on Earth-based systems and empowering spacecraft to autonomously adjust their trajectories in response to environmental changes. The potential of these biomimetic navigation and sensory systems extends beyond simple course correction. They could also play a pivotal role in enhancing safety and mission success. By improving a spacecraft's ability to perceive and react to its surroundings, these systems could prevent accidents, reduce the risk of losing essential functions, and ensure the continued operation of critical systems throughout the mission. Furthermore, incorporating such nature-inspired technologies could enable a more profound interaction between spacecraft and their environment. By closely mimicking the sensory abilities of animals, spacecraft could develop a kind of awareness that allows them to respond more dynamically to unanticipated challenges, from avoiding hazards to optimizing energy consumption. As we look to the future of space exploration, leveraging the wisdom embedded in natural navigation and sensory systems promises to usher in a new era of technological advancement. By observing and learning from the creatures that have mastered the art of navigation across our planet, we can design spacecraft that are not only more efficient and resilient, but also more attuned to the cosmic expanse they traverse. This integration of biomimicry into space technology not only enhances our capability to explore, but also reaffirms our role as students of the natural world, eager to adapt its lessons to advance our journey through the stars. As the sun rises on the next chapter, we delve into the fascinating concept of ecosystem-inspired space habitats. These innovative designs aim to create self-sustaining environments that replicate the intricate balance of Earth's ecosystems. Imagine future space habitats that function much like a flourishing forest or a vibrant coral reef, where every element harmoniously contributes to the overall system, ensuring sustainability and the well-being of its inhabitants. Forests, for example, operate on a closed-loop system where the waste produced by one organism becomes a resource for another. This efficient recycling of nutrients could inspire life support systems in space habitats, enabling them to produce food, recycle air, and manage waste with minimal external input. The goal is to establish environments where astronauts can live for extended periods, relying on their habitat's capacity to regenerate essential resources, much like the self-sustaining ecosystems on Earth. Similarly, the complexity of coral reefs offers another model for developing autonomous life support systems. Coral reefs are teeming with biodiversity, each species playing a crucial role in maintaining the reef's health and stability. By designing space habitats that emulate such ecosystems, we can create environments that support a diverse range of life forms, each contributing to the habitat's overall function. This approach not only ensures the survival of astronauts but also enhances their quality of life, providing a more natural and psychologically supportive environment. The advantages of these ecosystem-inspired designs extend beyond human habitats. They can also play a critical role in the cultivation of extraterrestrial resources, supporting efforts to grow food on Mars or the Moon. By mimicking the natural processes of Earth's ecosystems, these habitats could produce fresh food, clean water, and breathable air, reducing the dependency on supplies from Earth and paving the way for sustainable long-term space missions. Moreover, these habitats could improve our understanding of Earth's ecosystems by providing a controlled environment to study ecological processes and the effects of various environmental factors. Insights gained from these studies could lead to advancements in sustainable practices on Earth, highlighting the reciprocal benefits of space exploration and environmental stewardship. As we move forward in our quest for space colonization, ecosystem-inspired habitats represent a promising avenue for achieving sustainable and autonomous human presence beyond our planet. By harnessing the wisdom of nature, we not only enhance our capabilities to explore the cosmos, but also reaffirm our commitment to living in harmony with the natural world. By striving to emulate Earth's ecosystems in the vastness of space, we demonstrate our understanding of the delicate balance that sustains life and our dedication to preserving it wherever our journeys may lead. With the next phase of the journey in sight, we turn our attention to the exciting future trends in biomimicry within space exploration. As we look ahead, it becomes clear that the convergence of nature-inspired design, advanced technology, and innovative thinking is set to redefine how humans engage with the cosmos. At the forefront of these advancements is the growing synergy between biomimicry and computational biology. This relationship is poised to unlock new ways of understanding and replicating the intricate processes found in nature, ultimately guiding the development of more sophisticated and resilient spacecraft. By using computational models, researchers can simulate and analyze complex biological systems, gaining insights that can be translated into practical applications for space technology. Imagine spacecraft that adapt to the harsh conditions of space, much like organisms adapt to their environment, becoming stronger and more efficient over time. Another promising direction is the integration of nature-inspired designs with artificial intelligence. By harnessing the capabilities of AI, we can create spacecraft and habitats that learn and evolve autonomously, optimizing their operations based on real-time environmental feedback. This could lead to spacecraft systems that predict and respond to challenges with minimal human intervention, significantly enhancing mission success and safety. For instance, AI-driven adaptive systems could adjust energy consumption, navigation paths, or structural configurations to withstand space's unpredictable conditions. Ongoing projects also hint at a future where biomimicry leads to groundbreaking innovations. Among these are efforts to develop bio-inspired propulsion systems, which aim to improve the efficiency and sustainability of space travel. By emulating the propulsion mechanisms of marine life or the flight patterns of birds, researchers are exploring ways to create propulsion methods that require less fuel and generate less pollution, thus reducing the environmental impact of space exploration. Additionally, the potential to cultivate extraterrestrial resources using biomimicry is becoming increasingly tangible. Through these efforts, we envision settlements that support themselves by utilizing resources found on celestial bodies, reminiscent of how ecosystems function on Earth, thus minimizing reliance on supplies from our home planet. As biomimicry continues to evolve, it presents not just the prospect of innovative spacecraft, but also the potential for more harmonious interactions with our environment. This approach to space exploration emphasizes sustainability and resilience, reflecting a deep respect for the natural world. By aligning our technological pursuits with nature's principles, we stand on the brink of a new era in which human presence in space becomes both achievable and sustainable. The future of biomimicry in space exploration is not just about reaching new frontiers, it's about doing so in a way that honors the delicate balance that supports life. With each step forward, we're reminded that the lessons we learn from nature can guide us towards a wiser, more enlightened path as we explore the vast universe beyond. As the next challenge unfolds in our journey through biomimicry in space exploration, we encounter a landscape filled with both remarkable potential and significant obstacles. One of the primary challenges in adopting biomimicry is the sheer complexity of replicating nature's intricate designs. Nature has had millions of years to perfect its systems, and translating these into human technology is no small feat. For instance, mimicking the strength and flexibility of spider silk or the energy efficiency of photosynthesis requires advanced materials science and engineering capabilities that are still developing. This leads to technical hurdles that must be overcome to create viable solutions for space environments. Beyond technical complexities, ethical considerations loom large in the application of biomimicry. As we delve deeper into replicating biological systems, we must tread carefully to avoid crossing moral and ethical boundaries. One key concern is the manipulation of biological materials, which raises questions about the potential consequences of altering natural processes. As we replicate biological functions, there's a risk of unforeseen impacts that could upset ecological balances or lead to unintended consequences in other domains. The use of genetic engineering or synthetic biology in creating bio-inspired technologies demands strict ethical oversight and comprehensive risk assessments to ensure responsible innovation. Moreover, there is the challenge of sustainably scaling these biomimetic technologies. While the concept of self-healing materials or adaptive structures inspired by nature is compelling, their practical implementation requires resources that are often limited. Sourcing these materials sustainably without depleting natural resources or causing environmental harm is a crucial consideration. This requires a balanced approach where we weigh the benefits of technological advancement against the sustainability of our practices. Balancing innovation with caution is vital as we navigate the complexities of biomimicry in space exploration. It is a delicate act of maintaining scientific progress while respecting ethical boundaries, ensuring that our quest for knowledge does not compromise the very principles we seek to emulate. This careful consideration is not only vital for the success of biomimicry in space exploration, but also for maintaining our responsibility as stewards of Earth and the cosmos. As we look to nature for solutions, we must also reflect on our role in preserving its delicate balance. This focus on ethical and sustainable innovation highlights the importance of interdisciplinary collaboration. Scientists, ethicists, engineers, and policymakers must work together to develop frameworks that guide the responsible use of biomimicry. By integrating diverse perspectives, we can ensure that our efforts honor both the ingenuity of nature and our commitment to ethical stewardship. Moving forward, the path of biomimicry in space exploration invites us to not only explore the frontiers of technology, but also to reflect on the values that guide our journey. This dual focus on innovation and ethics will shape a future where human presence in space is sustainable and harmonious with the natural world. As we continue to draw inspiration from nature, we are reminded of the responsibility we hold to create a future that respects the intricate web of life from which we have learned so much. With the next phase of the journey in sight, our exploration of biomimicry in space is a testament to the boundless possibilities that lie at the intersection of nature and technology. As we reflect on this innovative landscape, it's clear that nature's time-tested designs offer profound solutions for crafting resilient spacecraft. These designs not only promise the structural strength needed to endure space's harsh conditions, but also embody the adaptability required for long-term missions beyond our earthly bounds. By drawing from nature's resilient strategies, we tap into an evolutionary vault of wisdom, crafting space technologies that are as enduring as the spider's web and as energy-efficient as the lushest forest. This journey through biomimicry reveals more than just technological potential. It unveils a philosophical shift in how we perceive and engage with the universe. By learning from nature, we don't just solve engineering challenges, we forge a sustainable path to the stars that respects and mirrors the ecosystems we leave behind. This respect for natural systems mandates a thoughtful integration of technological advancement with the preservation of ecological integrity, ensuring our strides into space don't disrupt the delicate balances that sustain life on Earth. Envisioning a future where space technology and natural wisdom converge, we invite you to imagine spacecraft that mend themselves like flesh, habitats that sustain life like Earth's own biomass, and navigation systems as instinctual as a bird's migration. Such innovations promise not only the feasibility of space travel, but also a harmonious existence within the vast theater of the cosmos. We encourage you to envision this future with us, a future where humanity's presence in space is marked by sustainability, adaptability, and humility. As you reflect on the possibilities, we invite you to join our community by subscribing to our channel and sharing your thoughts on how we can continue to learn from nature in our quest toward the stars. Biomimicry isn't merely reshaping spacecraft, it's redefining our relationship with the universe, inspiring a new era of exploration where humanity thrives alongside the wisdom of nature. Together, let's propel our understanding beyond the limits of what we know, guided by the intricate patterns that have navigated Earth through the eons.